And what the climate models suggest, and there were now other groups have repeated the same kinds of climate model simulations and came to the same conclusions, that if you offset only about, say, half of the warming, that basically everybody cools down a bit, but not necessarily as much as they would like to. But you're not overcompensating for the changes in rainfall, and that basically every region has a climate that's closer to what it was before we started putting CO2 into the atmosphere.
Hello, I'm Herb Simmens. I'm at the Climate Systems Engineering First Conference in Chicago, Illinois, at the University of Chicago. This is really, at least within the field of solar radiation management, kind of historic events where several hundred people from all over the country and the world are here today to talk about the progress that's been made and some of the challenges. And I'm so delighted on behalf of the Climate Emergency Forum to chat briefly with Ken Caldeira. Ken, I've followed your career a bit over the years, and you are one of the real pioneers, I think it's fair to say, in the whole field of what's now sometimes called sunshine reflection, solar radiation management, direct climate cooling, geoengineering. There are all sorts of terms. And I really appreciate you're here today. You gave a brief talk earlier today that I want to ask you about. The first thing, correct me if I'm wrong, but as I understand the story, you were the one who first came up with the term for solar radiation management or modification, and it's, at least to me, it was a wonderful story. I see you're smiling, so maybe you could tell us.
I forget whether it was 2005 or 2006, something like this. We were working with NASA to create a workshop, and we originally put it in as some kind of solar geoengineering, or geoengineering was in the name. And the Washington office of some part of NASA came back and they didn't want to approve it, and they thought that was too politically risky. And so we needed a name that would fly under the radar, so to speak. And at that time, the Department of Energy had a carbon management program. So we said, oh, why don't we make it solar radiation management? But we were like laughing, and because the goal was to sound bureaucraties and that people wouldn't understand what it is, and so it would fly under the radar and not get flagged by the bureaucrats. And so it's sort of ironic that something that was designed to obscure what we're talking about has become a dominant acronym in the field.
So there you go, the unintended consequences of government bureaucracy and trying to do something. And of course, 25 years later, it's not a whole lot less controversial now than it was then. Is that fair to say, Ken?
Well, we did the first solar geoengineering computer model simulations. Well, they were published in 2000, but done in 1998, 1999. And so, it's been well over 25 years that I've been involved in this. And when we first started, it was just a kind of thought experiment. We didn't think of it realistically. And then, it became controversial, but still kind of fringe. And now it really feels it's sort of entered the mainstream of the climate conversation.
As evidenced by this conference right here today. So you made a presentation, a brief presentation early on today, and you said something that I don't think I'd heard before, and I've been following, for better or worse, this field for quite a few years now. I'm paraphrasing, and you can correct me, but basically I think you said that we can now conclude that at least we can reduce temperatures that are already too elevated, not necessarily all the way back to where they were, but to some degree without necessarily making any country or groups of people any worse off than they are now, while we're basically alleviating some of the heat that affects all of us. And this is based upon, the sort of modeling that's not even atmospheric. So did I get that sort of right? And can you elaborate on that for a couple of minutes?
Well, first, last year we participated in the writing of a report, or maybe it was the year before that, from the United Nations called One Atmosphere. And we looked at the available scientific literature, and I guess there were a few key papers, but one was by Pete Irvine and David Keith, who were both here in Chicago, and they looked at a scenario where they just offset half the warming rate. If you compensate fully for the total global warming, because there's more sunlight at the equator than at the poles, that if you sort of reflect sunlight, you tend to overcool the equator if you cancel all the warming. And then also you start shifting rainfall patterns around. And what the climate models suggest, and there were now other groups have repeated the same kinds of climate model simulations and came to the same conclusions, that if you offset only about, say, half of the warming, that basically everybody cools down a bit, but not necessarily as much as they would like to, but that the rainfall patterns, you're not overcompensating for the changes in rainfall, and that basically every region has a climate that's closer to what it was before we started putting CO2 into the atmosphere. And so originally there was this idea, solar geoengineering, there are going to be winners and losers.
Right.
And really that's true if you offset 100% of the warming, but if you only offset about half the warming, the model suggests that basically everybody will have their amount of climate change reduced. And so that's led me to think of okay, I think we're in a new era of the research, because the research for the first couple of decades kind of assumed there'd be this sort of winners and losers perspective. And I think now we're in a thing like, well, the models are saying that a moderate kind of deployment, that everyone would be a winner.
A winner, yeah.
And so then that says, well, if that's wrong, let's find out about it now. And so that's why I've been advocating for a research program that kind of takes this, well, everyone could be a winner as the starting point, and then tries to poke holes in that.
So tell me there, I mean, this is based upon sophisticated models, but it's on computers. It's not up in the atmosphere.
Right.
So how confident are you and your colleagues that atmospheric modeling and testing and, maybe small scale deployment might contradict what the models say? In other words, should we rely? I mean, nobody's relying on what the models to say, let's deploy tomorrow. But how important is it, and how likely is it that we'll learn things that are so significant as to maybe counteract what we already think is true?
I mean, my basic bias coming into this is the Earth is a very complicated system, and any time you start interfering in a complicated system,
right,
there'll be some surprises. And my basic bias, even though I've been in this area for over a quarter century, is not to, I want to reduce interference in natural systems as much as possible. I think the dangerous thing is this, from an environmental point of view, what you'd like to do is tiptoe into a solar geoengineering deployment if you thought you would ever need it. And so you do a little bit more each year, and then if something starts going wrong, you back out of it. And unfortunately, what would be the least risky from an environmental perspective is probably least plausible from a political perspective, because it seems to me that the most likely modality that you'd see a real deployment would be somebody feels there's a climate emergency and we need to do something rapidly, and here's a way we can cool the Earth rapidly. And so, I think a gradual phased-in deployment would be the least risky environmentally, but I think a sudden let's turn on the switch would be the most plausible politically.
Okay. Well, let me ask you, because we said we'd chat a few minutes. We know you're busy, but I want to sort of ask you. You just said, I believe, that if we ever need to deploy it. Now, there are a small number of people, I think it's fair to say a small number of people, and I'm one of them, thinks that, believe strongly that as long as it can be shown, however that's done, to be safe and effective, that we need to start deploying now, because of all the things. We're already over 1.5, tipping points are being activated. Extreme weather is getting worse. It's going to take a decade or two to get this up there and whatever. And I know as scientists, you often like to stay away from policy questions, should we deploy or not? But can you give us some sense of whether you would disagree with me in my assertion that we should urgently try to see if it's safe and effective the same way drug testing is, which of course involves a lot of judgment. You know, there's no magic about safety. What's my safety might not be yours, but if it is, we should start trying to deploy.
I think this is a complicated question, and I think if I wasn't concerned about social responses, and I just thought, oh, what would, given that there'll be future carbon dioxide and other greenhouse gas emissions, what would be the course of action that would protect the environment the most? I would say is something similar to the kinds of scenarios that David Keith has been advocating, where you sort of slowly ramp in solar geoengineering to maybe cut the rate of warming in half. So you're just
But I mean that you start doing that soon, as
Yeah,
opposed
yeah,
to waiting for some signal that now we need to do it.
Yeah, I think that might be the path that reduces environmental damage from a physical perspective. And I think the thing that would give me caution about doing that is that I think if there's a too early a move towards deployment before there's some kind of, I don't want to say full consensus, but at least some broad, as close as you can get to a consensus on what you need to do.
Some degree of social acceptance.
That it might end up generating more opposition and maybe inhibit the longer term development. I mean, this has come up around the question of outdoor experimentation, that, many scientists think that we should be doing experiments outdoors, and I think I wish there was no controversy over it, and it could just be done like any other normal experiment. That I think like an organization that's engaged in outdoor experiments is going to have a tough time communicating that they're searchers after knowledge rather than developing a deployment capability, and that it'll be a real communication challenge. And so, I guess as I mentioned in my comments today, I think we need a governmental funded research program
to build the social acceptance.
And that, people like Dave Fahey at NOAA, who have been doing experiments in the stratosphere for decades. I think if you had a governmental agency that had experience doing stratospheric experiments, and then they did these experiments, that I think it'd be less likely to provoke all kinds of widespread opposition. And so I guess I'm a little afraid that moving ahead too fast might make it harder to get a
But of course, if we move ahead too slow, we may be too late.
Isn't
that the challenge?
Yeah, that's the challenge. But I don't think we can just. I think the current model, where it's been mostly philanthropically funded, there are limits to how deep the pockets of philanthropists are, and also they have a roving spotlight and get bored with things and move on. What I would like to see is use this moment when there is some philanthropic interest to try to build the foundation of a federally supported research.
And I would agree with you. Ken, I appreciate you taking the time today.
Thank you very much.
I know we asked you some challenging questions,
okay,
and
not at all.
Ideally you would like a little more time.
I'm fine. I'm fine. I can talk.
But thanks so much for joining us, and we hope to have a couple more interviews from this extraordinary conference over the next 2 days. Thank you, and we'll see you soon.
All right, thank you very much.